There are times when you deserve more than a coffee break. So make a cup of Mellow Birds. You'll find its smooth, mellow flavor turns an ordinary coffee break into a mellow moment. Mellow Birds for mellow moments.
Every day should have some.
Hello everyone and welcome to another Mellow Moments. Well, today it happens to be raining outside. It's actually pouring down, but here to make me feel more warm and cozy, I've got the hug in a mug. The Mellow Birds. Welcome to AA Mellow. Let's have a look what's on the box today.
Patrick Moore's horizon as we take our weekly gaze into the sky at night.
Good evening. I'd like to begin with a few news notes. First of all, Voyager 2, still on its way to Neptune.
I know what you're all thinking. I bet AA used to watch Games Master with Dominic Diamond and Patrick Moore in his monocle as the Games Master with his golden joystick. Yeah, that is true, I did. But I also used to watch The Sky at Night, as did a lot of people in Britain back when the country... Well, let's keep this mellow, shall we? Let's keep it mellow.
Still working well and sending back fascinating pictures. Just look at this. That is Neptune, and that large dark patch in the middle is just about the same size as the great red spot on Jupiter. And quite clearly, Neptune is a very much more active planet than Uranus. And then there are the Neptunian satellites. We've known of two. One of them, Triton, is large and goes around Neptune in a wrong way or retrograde direction. And the other one, Nereid, is small and has a very strange orbit, much more like that of a comet than a satellite. Now, Voyager 2 has revealed yet another satellite, about 200 kilometers across, closer in than Triton. And the most peculiar thing about this satellite is that it's not peculiar. It appears to be perfectly orthodox in size and in orbit. And we didn't expect that. And I think we may have to revise plenty of our ideas about the past history of the Neptunian system. Then you may like to see a picture the Russians have just released of the satellite of Mars, Phobos, above Mars itself. And this was taken, actually last February, and it's been released, by the rather ill-fated probe, Phobos 2, which of course went out of contact shortly after that.
I feel like there's not as much interest in space these days. They certainly don't have a show like The Sky at Night on anymore. I don't know what's on BBC Two now, but they definitely don't have kind of general interest stuff like this in space. In fact, the most you see about it is through Elon Musk, of course, but I feel like most people aren't interested in that either. Anyway, let's carry on.
It's just over 20 years now since men landed on the moon, and this has been remembered in many ways. Not least of all by the stamp collectors. And just look at these. These are sets of stamps based entirely upon NASA pictures. I am no stamp collector myself, but I'm quite sure these are going to be collector's items in the future, and certainly that was a great moment. Many people, I'm sure, will remember that moment when Armstrong stepped out onto the lunar surface. Another interesting phenomenon that happened quite recently.
Maths fans will have worked out that this is from 1989. Obviously, on AA Mellow, it's always 1991. So this is being repeated in 1991, according to the kayfabe law of this show, such that it exists. But 1989.
Was an occultation of a star by the main satellite of Saturn, Titan. Titan passed in front of the star 28 Sagittarii and briefly hid it. And this lovely sequence was taken by the Salford Astronomical Society. I actually observed that from my observatory down at Selsey, and I'm very glad I did, because it's very rare indeed, and it won't happen again in my lifetime. And just a note here for more serious planetary observers, apparently the south equatorial belt of Jupiter has virtually disappeared. At the moment, Jupiter is a morning object in Gemini. I've not been able to observe it for the past fortnight or so because of prevailing haze from my observatory down at Chelsea. But if you can look at Jupiter through an adequate telescope, do. Very interesting things are happening there. And now...
I just love the idea of the audience of this show. You know, you've got your stamp collectors and your kind of space hobbyists who've all got their own telescopes to look up there. Very healthy signs of more healthy time in a way. I'm really enjoying the coffee this morning. It's making me feel exceptionally mellow. Let's carry on.
On to our main theme. On the early morning of August the 17th, there's going to be a total eclipse of the moon, and most of it's going to be quite well seen from Britain, skies permitting. The Earth goes round the sun, the moon goes round the Earth, and so there must be times when the three bodies move into a direct line with the Earth in the mid-position. When that happens, all direct sunlight is cut off from the lunar surface, and the moon turns a dim, very often coppery colour until it comes out of the shadow again. And even when the eclipse is not total, it is quite spectacular. There's a picture of near totality, and you can see what I mean. But of course, things are not always quite so simple as they might appear. And for one thing, the sun is not a point of light, it appears as a disk. The Earth casts a shadow in space, and that shadow is known as the umbra. Mm-hmm. But because the sun's a disk, to either side of the cone of umbra, there is an area of partial shadow, or penumbra, and of course, the moon must pass through the penumbra before going into the umbra itself. Also, note here that the shadow of the Earth on the moon is curved, and that was one of the very first proofs that the Earth's surface is itself curved, and therefore the Earth is not a flat plane as people used to think.
Interesting. Yeah.
The cone of shadow is long, and we've got a model here to show you what's meant. We're representing the Earth by a table tennis ball, imagining that the sunlight's coming from the left, and we've made the cone of shadow here light, not dark, to make it clear to see. And there you can see the moon represented by a marble. And as you can see, the cone of shadow is very long indeed. The moon is rather less than 250,000 miles away from Earth on average, and the cone of shadow is over 800,000 miles long. And even at the distance of the moon, the diameter of the cone of shadow is well over 5,000 miles. Therefore, there's plenty of room for the moon to get inside it, and totality can, on some occasions, last for up to an hour and 3/4. But one thing you may ask...
Why is that shadow so big then? Why is it so big? Am I being thick here? Oh, I suppose if it's blocking the light, then the shadow would just be indefinitely behind the Earth. Is that right? Don't know. It seems like it shouldn't be that long. Anyway, let's carry on drinking the coffee. Very interesting. Very interesting.
Ask, if the moon depends entirely upon sunlight, and all sunlight is cut off, then why doesn't the moon vanish? Well, generally it doesn't, simply because the Earth is surrounded by a layer of atmosphere. Here we see the moon again, inside the umbra, but round the Earth there is a layer of air, and that acts as a kind of a lens and bends some of the sun's rays onto the moon. And therefore, generally, the moon doesn't vanish, although, of course, everything does depend upon the state of the Earth's atmosphere, and some eclipses are very much brighter than others. Note also that when an eclipse of the moon is seen, it can be seen from anywhere on the Earth where the moon is above the horizon, unlike an eclipse of the sun where you have to be just the right place at the right time. And that's why any one particular place on Earth sees more lunar eclipses than solar ones. The moon, remember, has no atmosphere, and the lunar rocks are very bad at retaining heat. And as the Earth's shadow sweeps across, there's a very abrupt drop in temperature. It can go from something like plus 160 degrees down to minus 110 degrees, very, very abruptly indeed. Although there are one or two areas which cool down less rapidly, and these are known, rather misleadingly, I think, as hot spots. And one of these is the famous ray crater, Tycho, there in the middle of the picture, 54 miles across with a nice central peak. And the fact that it cools down less rapidly than the surroundings is due entirely to its rather different surface texture. And then there's the strange case of Linnae, a white patch with a central craterlet on the dark Mare Serenitatis. You can see there to the upper right of that picture where I took myself some time ago. Well, it's been said that when Linnae is suddenly chilled by the Earth's shadow, the white deposit increases as though something is being deposited there. Well, I've often looked for this. I've never seen it. And on an airless world like the moon, you can't expect anything in the nature of frost. So, frankly, I don't believe it. All the same, it may just well be worthwhile having a look at the coming eclipse. And so now, let's go back to what's going to happen on the early morning of August the 17th, just after midnight. Now, the eclipse begins, the umbral eclipse, as to say, at 2:21 British Summer Time. Remember, that's one.
So I remember this. I actually remember things like the eclipse being an event, and everybody would go out, and my dad would be excited, and I'd wanna try to see it, and everybody, this was a thing. But I feel like nobody's interested in anything anymore, like anything at all. Yeah. Let's carry on. This is very calming. This show, very calming.
Hour ahead of GMT. Totality begins at 3:20 summertime. Totality ends at 4:56, and the entire eclipse ends at 5:55, though by that time, of course, the sky is going to be impossibly light. But you'll be able to watch most of it, and you'll see the Earth shadow sweeping across the moon. You'll come to totality, and then the shadow will decrease again until the eclipse finally ends. And at totality, well, who knows? It may be coppery, there may be lovely colors. We can't be sure. It depends entirely upon the state of the Earth's atmosphere at that time. Because remember, all light reaching the eclipsed moon has to go there by way of the Earth's air. If it's going to be spectacular to watch, even more spectacular to photograph. Now, I'm by no means a good photographer.
Did you say by way of the Earth's air? What does that mean? What does that mean, that it has to go via the Earth's air? Hopefully some science nerds will clear that up in the chat. Always interested to learn more.
And who better to tell us about it than Douglas Arnold? Welcome back, Douglas. Okay. First of all, what about film?
Well, essentially, as we've been seeing in your photographs, Patrick, it's a colour subject. And there are two types of film which we can use, all of us can use, negative, positive, and transparency, or positive film. They're both excellent now. The manufacturers have done a marvellous job for us, both as regards quality and speed. It's a question of advantages and disadvantages. A transparency film is very unforgiving of over or under exposure.
Look at his moon tie.
Exposure, but on the other hand, the subject, the image, is there in the film when it's processed and comes out of the developing tank. Negative positive film is much more forgiving of overexposure particularly, but there, whether it's a machine or whether it's a printer in the darkroom, he doesn't know what that original subject was, particularly if it was a rather nice coppery moon, so you have a problem on that score. It's really a question of personal choice. The vital thing here with the eclipse is exposure. Yes. Now, as you were saying, Patrick, things depend upon what the state of the Earth's atmosphere is. They obviously also depend upon local conditions. You were talking about Salzy, for example. Yes. So it's very, very variable. So the important thing is to make sure one brackets. If we establish a relatively a norm or a guidance exposure, which we'll be talking about in a moment, the essential thing is to make sure that one brackets either side, over and under exposure, whether it be an aperture, if it's a variable lens, or a shutter speed, if we're working with a fixed focus telescope, for example, to go at least one either side, and better still, I think, two either side, because with an event of this kind, I think it's rather silly to economize on film.
Yes, indeed.
Now, that's the thing there. Now, we have some guidance here in a table as regards exposures. Now, let's assume, therefore, 400 ISO film we're using, which is a nice average speed film. The moon has moved entirely into penumbra, and that basically is not much different from a full moon when it's normal. So it's a daylight exposure, which most photographers will recognize, 2/50th at f11. Now, the eclipse progresses, and we have a little nudge of umbra coming in on the left there, but there really isn't much difference, so it's basically the same sort of exposure. The eclipse progresses further, we have a half phase, and now we're beginning to alter the exposure because of the growing umbra. Here we've just gone down one stop, as you can see. The eclipse progresses further, we have much more umbra now, and we have a relatively thin crescent penumbra. Now, this is interesting because if we expose for the penumbra, you will see there 125th at f8. We have a lot of umbra, and now we can expose for that. It's much slower now, of course, a quarter at f2.8, quarter of a second.
I have no clue what he's talking about, ladies and gentlemen, at all. But I mean, I've pretty much coming to the last drops of coffee now. And when he's finished, we'll wrap up the episode.
We go on still further. Now, the moon, having moved totally into the shadow, it's not really much different from that thin sliver or crescent, so it's about the same exposure. And then we go right into the middle of totality, where we're 1 second at f2.8. And if, for example, you were using an f8 lens, a telephoto lens of some kind there, that will be as much as 8 seconds or perhaps even more, 10 seconds. And of course you can choose a faster film. We have now excellent ISO 1000 films, and there we have the appropriate exposures on the right column there. Now we can put this diagram into a photographic form from actual photographs which I took on the February the 20th eclipse this year from Egypt. That's about the limit whereby you have a penumbra crescent coming in. You have the penumbra, which is the orangey, predominantly orangey, large gibbous area of the moon here. Now that was exposed for the umbra. The penumbra is...
All right, that'll do. This guy is getting a bit tedious, but yeah, starting to be unmellow. Even though I was enjoying this, but yeah, it's a bit too much. Well, what's this bit at the end here? They're going to show us a bit of the eclipse. See if we can actually see it now. Let's have a watch.
Or in the dark room, you can take a couple of pictures. Let's assume that you have only a moderate telephoto lens, which is not going to make a main feature.
He's still talking, this guy. See if we can get to the... Are they going to show it? No. Oh, because it hasn't happened yet. All right. Okay, then. What's this bit? I saw that.
You can do it subsequently with copying, drop an eclipse moon in on that in the appropriate position.
At least there is plenty to do and plenty to see. Douglas, thank you very much.
My pleasure, Patrick.
Well, if we do miss this one, there is another total lunar eclipse on the 9th of February, but there won't be such a good one, and of course we can't depend so much on the weather, so let's hope for clear skies on the early morning of August the 17th. By the time the next program comes out, I'll be over in America awaiting the Voyager 2 pass of Neptune, and we're going to do our main program about that on September the 10th, which has given us time to get and analyze and interpret all the various observations.
All right, well, thanks a lot for that, Patrick. I'll be back tomorrow morning for another Mellow Moments. See you then. Stay mellow, ladies and gents.
There are times when you deserve more than a coffee break, so make a cup of Mellow Birds. You'll find its smooth, mellow flavor turns an ordinary coffee break into a mellow moment. Mellow Birds for mellow moments.
Every day should have some.